Great. Let's see. Bot Challenge is a way to put together Python with Minecraft. It is a way to get your kids engaged into programming. It's a wonderful program. What you're going to need to get started is you're going to need a current version of Minecraft. You're going to need to be able to connect to a server, so you'll need an account in Minecraft. You'll need Python 3, 3.4 works just fine, and you'll need to pip install Bot Challenge. And let's see, there's a web page from katharosada.github.io. Let's see, talking about the Bot Challenge. Let's see, this is the place for all Bot Challenge knowledge. Let's see. The idea is that you're going to be controlling a robot. So here's what the robot looks like. It's a pumpkin. Let's see. It has a face so that you can figure out which way it's facing. Let's see. Let's see. It can move up, down, left. Let's see. Move left, move right. It can also face in different directions. So it can dig. Or let's see. This is the. Let's see. Being able to place blocks and also dig are. Let's see. The best reasons to have a robot in Minecraft. So. Let's see. She's also got 2 servers set up. One is called europe.botchallenge.net or au.botchallenge.net. All you need to do inside the Minecraft, let's see, once you connect to those or one of those servers, is you'll be able to see your robot whenever you type in /spawn_robot. And if you don't already have a robot sitting in front of you, you can right-click and spawn a new one. So this is my robot. I'm going to assume, let's see, like all live demos go, this is going to be perfect, right? Okay, so what I have is I want to move this in a direction. And let's just say down. Let's see. I want to connect with, let's see, my son's account, and let's see, using that server, set up a robot with username server. Can everybody see that? Okay. Okay. All right. And give it the command to move down. And so, anyway, I switch back over into back into the game, and it's now moved down 1 space. So we can go any direction. We can give him a series of commands. We can put things in for loops. Let's see. My son's first idea was he wanted to place blocks in a wall shape. So it went. Let's say he did 10 blocks high, moved to the right, and then put that all inside a for loop. Anyway, ended up building a very tall line into the sky. Anyway. But let's see, he's able to figure out these the logical steps. He's traced it back and found out, oh, I needed to add something else here. So it was fun. It's interactive. It gets kids involved in programming. So highly recommended. Let's see. So far, any questions? All right. How do you get the code for it? It's GitHub, or let's see, katharosada. katharosada.github.io/bot challenge. Let's see, you can also download and run your own server as well. So anyway, any other questions? Okay, I'll be around if you have any others.
Okay, so I'm Cameron Owens. This is 1 year after being bitten at PyTexas, how Python saved my career and my marriage. So let me tell you a story about that guy in the center. That was me before PyTexas. Pretty embarrassing, right? So when I came here, I have a background in mechanical engineering, a little electrical engineering. So what can you expect from a mechanical engineer when it comes to programming and developing? Nothing. I was trying to put round or square pegs through round holes, as you can see. So when it came to my workflow, this is what I used. LabVIEW, MATLAB, great tools, but not really for building robots. And this is how it made me feel. Really frustrated because it wasn't a great tool and everything. So then it came along this. This thing called Python. I tinkered with Python a little bit in school, but it was, I never really dove into it. So what can coming to PyTexas do? Well, so let's start off with Git. So I work for Coreware Robotic Solutions. We build robots. And the developers that I worked with seriously did not use software version control. People with, advanced degrees in computer science. So seriously, not using it. Learned about some amazing tools from Continuum Analytics, thanks to Christine and the rest of Team Continuum. And we're using a lot of their tools now. I learned about GIS tools like open source versions, thanks to Dynamic Page. I'm not sure if she's still here, and Sarah, who couldn't make it. So yeah, they're GIS wizards. It connected me to some awesome people. It taught me of why I should use Jupyter Notebook / IPython notebooks. Pretty much made 2 years of my undergraduate studies useless, because it focused on MATLAB and other horrible tools. I learned lots of other crazy stuff. James, this means you. Stop exploding people's brains. And then how to build a strong party. That's probably one of my favorite talks from last year to transition. So why should you go to PyTexas? Because these are all the sponsors from last year, and it created an awesome circle of friends, people that I interact with, people that you guys interact with. It's a great way to network and to be able to develop and grow your skills. So what happens at PyTexas doesn't stay here. So Twitter, I think, is like the main way to stay sort of interconnected. So I'd recommend it. And there's lots of awesome other events where we can start sharing skills and everything. So mostly this is kind of a shout out to the organizers of PyTexas for putting together such an awesome event, as well as those that present. Because the things that you share, major thumbs up to you guys, because we all help each other, right? And so that's the last slide that I got to. How did this save my marriage? I'm not an angry robot anymore, so my wife actually likes being around me. I still work like 60, 78 hours a week, but I'm not so angry. So thank you, PyTexas.
Okay, so my slides are available online too. I was actively editing them before, so there may be like random loose things now. So j.mp/boom docker. So we just put up a Docker service that isn't public yet. So if this is recorded, I probably made a mistake, but that's okay. So if I log into my cluster over here, so I don't know who uses Docker yet, but so I've got a bunch of clusters running, and if I click, I create a new one. So let's say I created PyTexas, create. It's going to launch me a new cluster, but I'll just download one that I already had built, and I already have that downloaded too. So let's go to a terminal. Cool. And try things out. So I get the zip file back from the service. Oops. And it creates a folder here. And if I source the Docker environment, I immediately get back Docker. So no host, no like full setup. It's just straight to Docker. So let's do Docker. Oops. So I'm going to forget the port number I need. Da, da. 8080. Let's try that. I might as well run that in the background. Okay, so if I run Docker port, so I'm already running an image. Docker port, that guy. So this is my URL. So if I do Docker port, put 8080, I get back this URL, so curl blah, boom. So server up and online. That took a little bit, I don't know how much time I have. Say 30 seconds-ish? Yeah, okay. Not all the other stuff. But let's run another. So I'm gonna run it a second time, and that's okay. If I try to run it a third time, this should bomb out, and that's okay. So what's running here is a Swarm cluster, and so I already had 2 nodes going, and so it just allocated a server to each one on that specific port because I requested port 80, and each of these are going. And I already had these set up for DNS. So if I go to little cloud dot, man, that's tiny. I can zoom in that, but not the rest. There we go. And there's a server online. That's all. If anybody wants to try this out and they have a Rackspace account or wants to sign up with one, come see me at the booth, and yeah, I'll get you a Docker environment to play on. Cool.
Hi, my name's Stephen Cassidy. I'm a freelance software developer from Houston, Texas, and all my handles and any website I use are Steve Martingale. Give you some Twitter love. I just started using it. I'm way behind the times. So for a while, I've been interested in stream processing. Ever since I heard like Nathan Mars's talk where he introduced Apache Storm. And then later he started talking about the Lambda architecture. So I read about that and thought it was cool, but I never had a good opportunity or like a use case for it until recently, where I was working at with a manufacturing company, and another team was, well, I guess back up. They have PLCs, which are programmable logic controllers, and that's what they use to like control machines that make stuff like stamp out parts or injection molding or sort of anything in a factory. It's going to be set up that way. And they're trying to have data on that and have a dashboard in real time and contract out to another firm. They had a lot of problems, and I thought, well, wouldn't that be a good use case for stream processing? So I kind of created a trivial example where we can use it. So I'm just going to go through that with you. So the example, we're pretending that we're like a toy factory and we injection mold toys. So we have PLC for our toy injection molding machine, and we go through it. So basically we have, is that big enough? Guess so. So the first step is, oops, I simulated the PLC sending machines, and so I wrote this little utility thing to sort of like create 4 fake or 8 fake injection molding machines, and they send a message periodically with just their temperature and their number, and they send that message after they've successfully made a toy. So this is kind of the code that sets that up and makes them vary a little bit. So that then hits an API I wrote in Flask, which is really tiny. I just realized I misspelled temperature. And so it receives that and puts it in Apache Kafka. Apache Kafka is a distributed pub sub system. It's, I think, created at LinkedIn, and you can have topics, and that's like sort of where you put messages into different, messages have topics, and you have producers, which are things that put messages into a Kafka topic, and then you have consumers, which consume from a topic. So in this case, I have, it receives the message from the simulator and puts it in Apache Kafka. So the next thing is this is the Apache Storm part, and this is so Storm has spouts, bolts, and tuples. A spout is, I guess back up, Storm is like streaming Hadoop made by Nathan Mars and then used at Twitter. So this consumes from the Kafka topic called sensor temp, and then parses the data and then emits it to bolt, which is then going to transform the data. Here is the bolt, which just counts it and updates for persistence reasons, I'm using MongoDB. So it updates the count that each machine has made and its current temperature. And I use Mongo because it would give me easy WebSockets with Meteor. And all of Storm is, all this goes together and is called a topology. So let me just run it real quick. And so now, so I just started the simulator. And here we go. Now they are updating in real time. And so we see the temperature and see if it changes. If it's over a certain danger setting, it's red. And I'm a little disappointed with how fast Meteor updates. But anyway, but the value of this kind of stuff is that with Kafka, you could have other consumers. So you could have your live dashboard, but the same topic, you could have a process listening to it for maybe inserting it in your data warehouse process. Or alerts, right? So maybe if a machine makes too many one parts or gets too hot, text or email somebody so they can fix it. I don't know, it's kind of a silly example, just wanted to play with it, and I'm gonna put it on GitHub in probably the next few days, but that's it.
Hi everyone, I'm Amin Momin. I work at MD Anderson and I manage one of the big bioinformatics groups there. And I have recently started to use Python, and I saw the demo for the IPython notebook a few months back at a meetup, and I was really impressed at how you can merge and mix both string data in Python with R for data analytics or graphings. And so I have previously used a lot of Python, R and Perl for my most of my genomics analysis as well as data mining purposes. But I thought I'll start giving it a try. And the past 2-3 months, I've been using a lot of R and Python together in this thing. So what I'll show you is a brief example of what I've been trying to learn. And I've picked up a lot of new things here as well as the other Python meetups. And I'll definitely improve my skills and use of Python. Oops. So what I've been trying to do is basically create a library of all the mutated peptides that are known to be present in cancer cells so that we can use this as a reference database to look for similar mutated proteins in our clinical and research data. So to do this particular task, what I had to do was get the list of all the mutations that have been identified previously from a database known as Cosmic, read it as a pandas table, then merge it with other databases from SwissProt, and then run some Python. And all this stuff was done in Python using pandas, BioPython, and other libraries. So here's a brief example of what we did. So we basically import all the libraries that we need, a whole bunch of libraries for transforming this data. We read in these mutation files as a big pandas table. We needed to add extra annotations to this. So we read the annotations from another ensemble database using the BioPython's module. And once we read these two tables, we merge them in pandas to make a larger table. And we also add all the positions where we need to mutate the peptide sequence, as well as the IDs that these proteins belong to. The second part was to actually import the sequence database that's available on the European consortium, and then index this entire database, which is about 2 gigs in size. It's basically a flat file. You index the database. And you can, that's how you can just pull out the protein sequences you need without looping through the entire 2 GB of data. So once we do that, I wrote a code then to take the data from my pandas data, and then just, one by one just loop through this entire index database and pull out all the proteins and then make the mutations that we need, so that now we can use this sequence database in our workflow. And this is just an example of what I've done in the last month or something, just trying to learn Python. And I think it's a really good use of Python, and I'll probably be using a lot of the graphics libraries as well as some of the other automation libraries that I'm hearing here. But yeah, this is a great example of how I can use this thing. Thank you very much. And going forward, I'll probably develop more. I've seen a lot of people using classes and more sophisticated packaging of this code and stuff like that. So once I develop the basic code in IPython notebooks, I can go back and actually write classes or functions to do this in a more professional manner with better graphics and stuff like that. Thank you very much for your attention.
All right, so we've had a number of talks about like Docker and IPython and things like that. Maybe you want to kind of play around with both of these things at the same time. Lots of people have published lots of IPython notebooks. Maybe you don't have IPython installed and all side toolkits and things like that, and you just want to get up and running really quick. Well, as you've seen, Docker is really cool and easy to use to get a lot of software complex environments up and running. And luckily, there's Docker containers that have already been built related to getting SciPy and IPython up and running. And so I figured I'd just go ahead and show people the kind of stuff that you can do. So, you can go over here and have like a, Linux computer running Docker. And from here you can do like a, let's see. And so when you go ahead and grab this, it goes ahead and grabs all the latest versions. I've recently pulled it, and so it just checked to make sure that everything's up to date. We've got everything needed for SciPy and IPython now on the computer, ready to go. All we need to do is go into here and run a little tiny single line command here. And we can make this, leave that as make a password.
Can you increase the size?
Oh, okay. Not easily. Is it really hard to read? If so, I'm sorry. So anyways, so now we have the container up and running, the SciPy server, and we also have Mark Adams' awesome guestbook application if anyone missed that. So we can go back over here now and open this up, and we did. Uh-oh, no certificates. Ignore certificate warnings all the time, right? And now we can log in. And here we go. Now we got a fresh run of it. And we can go back here and say we're done with this and we don't need to worry about all the resources it's using. We can do like Docker and stop that container. And you can also look at previous containers that were running with the -a command. And oh look, I have another SciPy server I was running earlier. So I can go and do docker start and then the container name. And switch back over. And then when we connect, here we have a bunch of Python notebooks from Christine's talk about machine learning on Friday afternoon and whatnot, and ready to go in and run and everything else, ready to go. And so this is just like a brief introduction on, both merging the Docker, the thing we've been talking about for a while, and IPython, which is pretty heavily used here. So, any questions? Thanks. Yes?
I'm just holding yours up.
Oh, okay. Yeah, all right.
You got 30 seconds, break dance.
Okay, yes. Okay.
I don't actually remember what I was supposed to talk about. I think it was about something I did a while back. And then in the process of getting those notes together, I decided to do a little bit of playing. And I came up with something very interesting. And I think this is actually really, really cool. But you may have your own opinion. Unfortunately, the first pass of it, I have no records of it because I didn't even keep the code. But I have a screenshot of it that I sent to somebody. It's a little puzzle. So it turns out in CPython, every time, we know it's a virtual machine and we know it's a stack-based virtual machine, which means every time you need to do something with the variable, it has to be pushed onto the stack so something else can pop it from the stack, right? Well, I went into the CPython interpreter on a whim, and I found that every time you push something onto the stack, it uses this macro called basic push. I turned it into a function, so I could then, in the bottom pane, set a breakpoint. In the bottom pane, it's actually kind of neat. I'm sending a sig trap to the own running process. So if you run this Python script from within a CPython that itself is running within a debugger, it'll drop down to your debugger. So then what you can do is you can run Python in GDB, which I do all the time, as most of us do. And what you can do is you can tell it to put a breakpoint every time it sees that variable. So what you end up with is you can see every use case of the variable. But unfortunately, this is a little bit obscure. So what I did and what I've been scrambling to do over the last 10 minutes is to actually do this. And this, I think, is really, really cool. So with about 15, maybe 15, 20 minutes of hacking around the CPython interpreter, as I said earlier today, the code is very easy to read through. You know, there's a little bit of tedium. You have to be willing to sit down and read through all the pieces there, but there's not a lot of complexity or inherent difficulty to it. You can add something that you might call read watches. So we're familiar with the sys module having line profiling, so every time you hit a line of the code, you can call a hook function and debuggers. Well, you can add read watches to Python, which means here we have two objects, right? I can import sys, import sys.setWatch. And every time something looks at this object, it calls my hook function. So for example, you have some big piece of code, and it's this really nasty object-oriented mess, and it pulls in some variable, and you have no idea where it even goes. You have no idea where this data is being sent. Set a hook on it, and every time that variable is looked at, touched, modified, read, written to, reassigned, anytime anything has to do anything with that piece of data, it calls your hook function. It's interesting you can do some really neat things with this because if you think about it, since you have the ability to hook into any possible access to the variable, you could just raise an exception every time somebody looks at that variable. So you could implement a very interesting form of sandboxing here because you could identify, you could set a watch on certain pieces of data, certain objects, and objects by ID, and then every time somebody tries to load them or look at them or read them or modify them, raise an exception and say, no, can't. Sorry. So you can do some really interesting things here. I actually thought this was really cool because this is, I think, a very common debugging use case for me. I have some big system, and somebody passes some argument in, and it gets passed down the line, passed to another function, to another function, to another function. I have no idea where it's ever even used. Now I can just set a watch, and I can see every single function where it's used. So I'll show you some use cases. Say I have a function y, or function f, and it just looks at this variable that's passed, and I call it with x, the one that I put a watch on, it tells me it sees it there, right? Say I have some closed over function, and it looks at that too. I don't actually know if this works, but. And it's egg faults, but it's a work in progress. So you can see that sometimes these things are a little bit harder to do than you might think, but you can see it's actually a really interesting idea, and it turned out to be pretty easy to do. And with maybe a little bit more work, we can get this to work in the closure case as well. Thank you so much.
It's entirely possible that many of you are unfamiliar with Conda, the package manager, and so I'm going to run through a few quick tips, but being that it is Catterday, I don't know if anyone celebrates Catterday, but instead of keep calm and Conda install, we will do lolcats in Conda install. And I'll interact with a variety of cat-based memes. That's an excellent question, Mr. Orange Cat. Conda is a package manager that is language agnostic, cross-platform. It works on Python, R, Java, Scala, And also for platforms, which is across OS X, OS 10, Linux, Windows. If you're a cat with a Raspberry Pi, ARMS version 6 and 7, and Power 8. Another excellent question, Mr. Puma-looking cat. You can kinda install all kinds of things. If you're running the latest, Python 3.5. If you're stuck in the past, like some sort of animal, Python 2.7. NumPy. Pandas, if you want to do some analysis with tabular data. Flask, Mongo, Spark, and R, and all kinds of other great things. Moneycat here would like to know how he can get the Conda. Well, good news. It is free because it's open source and BSD licensed. So you can either grab that off of GitHub, or it is shipped in both Anaconda and Miniconda. Anaconda is Python and Conda and a bunch of packages, either when you're downloading about 150 or available through the repository about 330 for scientific computing, or as the kids are calling it now, data science. Or if you want a lighter weight, you can go for Miniconda, which is just Python and Conda, and so you can bootstrap your environments that way. Whoa, super angry cat. I know about pip and virtualenv too, but wait, Conda is ever so slightly better. The differences between Conda and pip being pip is Python packages, Conda's language agnostic, so you get other packages. We talked about Julia, Scala, R. It'll handle environments natively. You're not waiting to compile from source because you're getting binaries. And it does all of the environments instead of just Python environments. But as James would probably say, don't do this, but you can use Conda and pip together. The way that you might want to do it the once is taking and building the Conda package from PyPI. And you can do that with Conda skeleton and then Conda build, and then you can upload that to Anaconda Cloud, which we'll talk about in a short moment, a very short moment. We're gonna go start going faster. We have 3 reasons to use Conda. If you have data science projects, maybe you have more packages, the private packages. We have Anaconda Cloud, which is at anaconda.org that you can take. It's a sort of a GitHub for binary packages. What if you're a data scientist and you use R? Fantastic, fancy data scientist cat. Anaconda Cloud also has R packages. If you're a data scientist that does not do packages, environments, excellent. You can use YAML to describe your environment and then share it with other people so they can reproduce your work. You create and activate your environments like so from the command line. You can freeze your versions, so what you're seeing is the same thing that someone else will be if the versions increase. And Anaconda Cloud we talked about. So in short, Conda, all of the things. You can look over documentation. It's at conda.pydata.org. If you want to hear more about that, Christine wrote an excellent blog post putting you well on the track to having amazing superpowers. I am Jeremy from Continuum.io. Keep calm, Conda install, and if you stop by the booth tomorrow, we have 2 of the Raspberry Pi units which we recently released Conda for, and we would love some of your help. Tell me which packages you'd be interested in, Conda packages you'd be interested in building, and 2 of you will go home with those to help us out at the end of the day. I'm Jeremy Tanner, Penguin on the internets, but this was mostly the work of the fantastic Christine. Data!